Without further ado, let's start our presentation for our paper titled Building CNN Architecture to Identify Environmental Sound in Videos. So, please, my friend Fatan, to take over for the next slide.
So I would like to explain the background. Videos have been a large and growingly popular media format in modern society. Its function to spread information can be used as a method of education and entertainment. Although videos are very versatile, there are still a percentage of the population that cannot fully reap the benefits of video. These are people with hearing impairments. According to a research done by Simon Angeli, 10% of the world population have hearing impairment. This means that they cannot fully immerse themselves in video content. For this reason, we try to create a CNN structure to identify environmental sounds in video. Why environmental sounds? It is because most auto captions only caption and only sorry I mean caption the dialogue and not the environmental sounds. This means less immersive experience for people with hearing impairment to enjoy a more entertaining types of video. So we can next.
Okay, now I'm going to explain the CNN model for audio classification. We're going to train the model for a different sound classification task. As you can see, we have three models, namely DeskNet, ResNet, Inception, and we also have three datasets, namely GTZen, ESC55, Urban Sound, AK. Now we have the result. The result is that DeskNet has the most high accuracy, and Inception has the most low accuracy. Next, I'm going to explain a deep event network for multimedia event detection and evidence recounting. As you can see, we have the illustration for infrastructure of the DevNet. And at first, we're going to pre-train the DevNet using the ImageNet. And then we fine-tuning them on the Met videos dataset. As you can see, the parameter is moving to the left side after we fine-tuning them on Met videos. Next.
So that was the literature review for our paper. Next, we move on to our methodology for our paper. So first, our dataset is that we use ESC50 that is created by Karol Pizzak. So the dataset itself has 2,000 audio recordings of environmental sounds and are divided into 5 classes with 10 more subclasses. So to the right, we have methodology overview. So first, we convert our raw audio waveform into Mel scale spectrogram using a short time Fourier transform, which is a signal processing technique used to analyze the frequency of the content of a signal over time. So the reason we are using STFT is because, according to a research done by Muhammad Huzaifa, where he compares a different time frequency representation for CNN input, the log-mel spectrogram that is converted using STFT yields the best output in accuracy. So here we move on. Next, we are going to input the process data into our CNN architecture, which will then output the output will be the prediction, the classes. Now, here we have the CNN architecture. So the details of the CNN architecture. So the CNN architecture has 4 layers, 2 convolutional layers, and 2 fully connected layers. So each convolutional layer is followed by max pooling layer to reduce dimensionality of the data. Now, the first convolutional layer also acts as its input layer, and the first convolutional layer comprised of 8 filters and a 4x4 kernel size with rectified linear units or ReLU activation functions. And then the second convolutional layer, CL2, we have 12 filters and a 3x3 kernel size with also ReLU activation function. Now for the next two last layers, we have the first fully connected layers, which consists of 64 neurons and a ReLU function as its activation function. Now the last fully connected layer is the output layers, which mean that the number of neurons must be the same as the number of classes in this dataset, which means we have 50 neurons, and also a softmax function because it is an output layer. So those are the models. The model is then trained on 100 epochs and 32 batch size. Moving on to our result and evaluation. So here we can see in the graph, we can see the validation accuracy of 41%. And furthermore, the graph also shows the training accuracy actually reach 1%, which indicates overfitting. In the table, we can also see the other CNN models that used for environmental sound classification. The table shows that our result yields the worst result. And even when compared to research done by the model done by Kamfaria and Tokozuma, which uses raw data as its input. So what can we do to improve our result? So from after evaluating our result, we conclude that maybe we can add more filters and increase the kernel size such that the convolutional layer can get a clearer features of the spectrogram. And also to reduce the overfitting, we can add a regularizer or to the convolutional layers, and maybe we can also add a dropout rate during training, so such that overfitting is reduced during our training. So in conclusion, what can we conclude from this research? So in conclusion, is our paper aims to make a CNN architecture to be used in automatic captioning of a video so that it can input an audio data as its input and produce a caption. However, because our model still has a relatively low accuracy, we conclude that this research can still be improved upon, such by maybe changing the hyperparameters of the model. And there we go. That is all from us. Thank you very much for listening, and have a great day.